Welcome to today's tutorial. For today's lesson, we are going to be proving that the expected value of sample variance is equal to population variance, where we all know that sample variance is equal to the summation of the deviations of each of the sample all squared from the mean. So everything all over n minus 1, right? So now, if we are to apply the expectation to both sides of this equation, we have that the expectation of s squared is equal to the expectation of the whole of this summation x minus x bar all squared, everything all over n minus 1. Here now, we are going to factorize out this denominator, because for now we are not going to be using it in this proving until the ending part or the final part of this proving. We will need it. So when you factorize it out, you have this expression to be equals to e over n minus 1, everything bracket summation of, if you are to expand this bracket also, if you are to expand this particular bracket, you have it to be what? X squared minus 2x x bar plus x bar squared. From the knowledge of what? From the knowledge of expansion, we have expanded this. This is what I used in expanding it. This particular expression is the same thing as what? X minus x bar all squared, which means you have to write this in two places. X minus x bar, x minus x bar. Then use each term here to multiply the terms here. When this multiply this, you have to be equal to x in bracket, everything here, x bar. And the same thing here, minus x bar, multiplying everything here, x minus x bar. And I'm going this times this will give us x squared minus this times this minus x bar. This times this minus x bar x. This times this it will give us plus minus and minus plus x bar all squared, x bar all squared. So this and this are the same thing. This time are the same. So now it will now be equal to x squared minus 2 of x bar plus x bar squared. So that is how I arrived at this, expanding this. So next up, we are going to be distributing this summation sign to each term in that bracket. So you now have it as this bracket what? When the summation sign is distributed, you have it to be summation what? X squared minus 2x bar summation x plus summation x bar squared. The summation for the middle term of this expression we just expanded, the summation did not affect 2 and the mean x bar, because of what? They are constants. So it affects only x, which is not constant. So now, from here, we know that what? Summation x is equal to what? N x bar. Because from the formula for sample mean, we have that the sample mean is equal to what? The summation of the samples all over the number of samples, right? So now when you cross multiply this to get this alone, you have it to be equal to what? Summation x being equal to n x bar. We now have it to now be equal to the expected value all over n minus 1 bracket summation x squared minus 2x bar. Instead of summation x, now we are going to be putting nx bar rather, since we just proved it here. So now put it to be equals to multiplying what? Nx bar plus, here this x bar here is the mean, and we know that it's actually a constant. Is a constant. So if you are summing a lot of constants, let's say we are having 2, it will be what? It will be the number of that constant, 1, 2, 3, 4, 5. It now be n times 2. The n here is what? How many are there? 1, 2, 3, 4, 5 is 5. So it will now be 5 times 2, which will give us 10. That means if you add this thing, you will get 10. If you do it this way, you also get 10. So the summation of constants n bar squared is the same thing as the number of that constant, right? Is cleared. So from here, we have this expression to be e over n minus 1, all in brackets, summation x squared. The summation here continues because this is not a constant. There is no way you can reduce this expression here, this term here. So you continue with it, minus n. This, if you are to merge this, you have it as nx, or rather, it will be 2nx bar. N x bar multiplying x bar give us x bar squared, and our n here is it, our 2 here is it, right? So now plus nx bar squared. Now you see you have two of these with negative sign and positive sign of. That means, for instance, you have 3x plus 2x minus 3x plus 2x. Automatically we know we are going to be having minus x, right? So in this case, minus 2nx bar squared plus nx bar squared will give us what? Minus, sorry, it will give us minus nx bar squared. So this will now, the whole thing will now be expected value all over n minus 1 of bracket summation x bar, right? No bar, sorry, this is what I'm writing, summation x squared minus this. At this point, we are going to be distributing e to the terms in brackets. We will now have it to be equal to what? 1 over n minus 1 bracket. E multiplying this will give us summation of estimation value of x all squared, right? Minus n of estimation value of x bar all squared, right? So from here, we all know that this particular things, this expected value of x squared and expected value of x bar squared have formula. They have their values in statistics. For this, e of x squared, it is equal to what? This squared plus population mean. It is equal to the population variance plus the population mean. That is the expected value of the population mean all squared. Okay. This is another way of writing population mean. Either write it as x or mu. So the expected value of population mean all squared is equal to the variance squared plus the population mean also squared. Sorry, I missed the square here. Also squared. And for the expected value of the sample mean, the x with bar is the sample mean. So, and for the expected value of the sample mean x bar all squared, it is equal to what? The variance of the sample of the population all over the number of samples plus the population mean all squared, right? So from here, in place of this particular expression here, we are going to be substituting this, and in place of this here, we are going to be substituting this. So on doing that, let's use this next page to do that. On doing that, we are going to be having this. Let me repeat this expression before my substitution. We are going to be having that 1 over n minus 1 bracket summation of the estimation of expected value of x squared minus n expected value of x bar squared is equal to now 1 over n minus 1 bracket summation. When you are adding this, summation means you are adding the number of this, right? The number of this. So you are going to be putting your n there, the number of that thing you are adding. I explained it earlier when I used to 5 places. So now I'm putting your n. This already, the estimation there already is equal to this. So you substitute there that. You substitute that in place of expected value of the population mean or squared. You now have it as sigma squared plus mu squared, right? Minus n of this already. We say this equal to this. So now have it as bracket sigma squared over n plus mu squared. Okay. So now from here we are going to be simplifying this expression. We are going to be simplifying this expression. Simplifying this, you have that it's equal to 1 over n minus 1, right? Bracket. This is the same thing as n sigma squared. When you use the n to open the bracket, plus n mu squared minus n times this will give us all over the initial n, where this will cancel this, plus minus n times plus this will give us minus. So here is going to be minus n mu squared, right? So now this expression remains. So you now have it to now be equal to 1 over n minus 1 bracket n sigma squared plus n mu squared minus sigma squared minus n mu squared, right? So now you can see some terms can cancel out. This can cancel out this, then left with this. So you now have your expression to now be equal to 1 over n minus 1 bracket what? Bracket n sigma squared minus sigma squared, where if you factorize out sigma, since they are having sigma in common, sigma squared in common, you factorize it as you have it to be 1 over n minus 1 sigma squared bracket what? Bracket n minus 1. And you factorize sigma out, you have n minus 1 left in the bracket. So now it is clear that this will cancel out this. You are left with sigma squared. Therefore, we have successfully proven that the expected value of the sample variance is equal to the population variance.